Good day, and welcome to the Leader's Edge, where we give actionable insights to help you thrive in a new normal. If your business succeeds or fails based on the quality of your software, this is the right show for you. Whether you're the head of a startup, a CEO with a non-technical background, or project leader for software development, we will learn a lot from this special guest. Join me in welcoming to the virtual stage Dr. Allan Scherr. Allan Scherr, welcome to the show.
Thank you. Let me start the presentation. So I'm talking today about developing what I call investment-grade software. This is the first part of a two-part summary, and that summary is basically an abstract of an all-day course. And at the end, I'll show you a link to find out more about it. First thing I want to do is just explain who I am. I have a PhD in computer science from MIT. I've spent 30 years at IBM developing software all the way from microcode through operating systems, middleware, and applications. I've shipped millions of lines of software code to the field. In fact, I used to brag that I probably shipped more bugs to the field than anybody else who worked for IBM. I was named an IBM Fellow and an IEEE Fellow for my technical achievements, and I spent, after IBM, 8 years as Senior VP Software Engineering at EMC, which is now merged with Dell. So I've spent a lot of time doing software development. Using the principles I'll be talking about, my 200-person engineering group at EMC shipped committed function on time and under budget every quarter for years, actually more than 3 years, which I think is remarkable. There's an old joke in the software business that in the last 50 years, we've had 2 years of experience 25 times. The reason I say that is because people don't know about problems that were solved 50 years ago, 10 years ago, 20 years ago, and therefore the wheel keeps getting reinvented in many cases. Just to give you one example, 50 years ago, the telephone system in the United States achieved an average time between failures of 40 years. And when I ask people if they know how they did that, nobody knows. I mean, I know how they did it, but the average software engineer has no idea. So we're going to talk some about what kinds of things you can do to get that kind of reliability. What's wrong with today's software? Well, bugs is probably the number one. I find bugs everywhere. User interfaces are inconsistent. What used to work sometimes stops working. They're hard to understand. They're inefficient. Reliability problems are everywhere. I mean, websites out of operation. I used to collect screenshots of websites saying of major banks saying, you know, we'll be back in a while when we fix our problem. Data's lost. You have to power down and reboot to correct errors, security issues, and so on. And the reason the list is cut off is because I didn't want to spend a lot of time on it. Most of you know what the problems are. If you look at some of the issues, I mean, look at the Boeing 737 MAX, which seems to have crashed because of software issues. So I always ask people, if you were in a self-driving car sitting in the back seat and nobody was behind the steering wheel, how would you have liked the software to have been developed? And I'll tell you how I'd like to see it developed. Okay, so I'm gonna first talk about what I mean by investment-grade software. Then we'll talk about organizing software development optimally. Talk about usability and how do you design software to optimize building it and testing it. And in part two, which I'm not going to cover in this presentation, we'll talk about overall development process choices, how to test rigorously, how to manage the backlog of unfixed bugs, reliability, and finally, organizational integrity and the role it plays in being able to do all these things. So what I mean by investment grade versus junk is exemplified in this cartoon. I mean, we all know what junk food is. This cartoon was designed to show you what junk bonds were, as opposed to investment grade bonds in the bond market. And I view software the same way. It's either junk or it's the kind of software that the money you spend to do keeps paying off. So what I mean in detail is software that doesn't have to be replaced, where new versions can be built upon the previous one, where the function, usability, reliability, security, and performance continuously improve, software that can be worked on harmoniously by multiple people doing new development, as well as fixing bugs from the field or from users, software that's upward compatible so that what used to work still works, software that's adaptable to new use, so you don't have to keep rewriting the same function over and over again, and the need for new code being minimized, and therefore costs go down. So you can introduce new function, new capability quicker, and with less code, because every time you write a line of code, you have the chance of introducing a bug. This cartoon by Scott Adams kind of shows what the trade-off is. I'll give you a second to look at it.
Yeah, I love Dilbert.
Yeah, so I do too. If you agree with the pointy-haired boss and the bald vice president, then you should probably just turn me off at this point, because we're going to talk about what it takes to do a good job, not a poor job.
Yeah.
So first topic is organizing software development. Let's take as an example a product that has two components, a front end and a back end. And we're doing what's called feature development. So you have a team that's doing a feature, and what they're going to be doing is making changes to both the front end, the back end, the data storage, and the user interface. And at the same time, another feature team is adding another feature in parallel, possibly on a different schedule, later schedule, but they're making changes in the same areas. In some cases, changes that that can conflict with one another. So this way of organizing has issues, namely that you have all these different people changing the same product base. And so you have to coordinate somehow the user interface changes, the stored application data formats, the procedures, and the function. This is what such an organization might look like. Teams that do features, and then a team that's doing maintenance, which I define as fixing bugs that are found when actual users use the software. Cross-feature coordination is basically worrying about release-to-release upward compatibility, user interface consistency, data model consistency, and product architecture integrity. And then support has to do with testing new function and making sure old function continues to work, and handling the libraries and version management. These staff functions typically are subservient to the people doing the features. So the feature guys typically rule these kinds of organizations. I'm exaggerating a little bit, but we're looking at extremes here just to make the point. You wind up with the feature guys who are doing the feature software being in charge, really. Another way to organize is to organize by component. So you have an owner of the user interface component, the database component, et cetera. And these groups, in effect, own the code that is that performs these functions. And now, because they own the code, they're the only ones that make changes to it. And typically their orientation is quality of the product in terms of usability, reliability, bugs, and productivity of doing new function and new uses. The staff functions now then worry about interfaces between the components, dependencies, that is, which components can use functions in other components, and then the version and release and feature planning in terms of when new features are going to be available to the users. Support functions are pretty much the same as with the other approach, where you have release testing and version management and the library management. Component organizations typically own the source code for their component. They're responsible, as I said, for maintenance. They coordinate all the changes made to their component, and they have specialists. So if you're doing the user interface, for instance, they have people that understand human factors, and they keep things consistent. And I'll talk later about some of the technology associated with doing that. Their goal is to maximize productivity and quality. If you look at the difference between product management oriented organizations, that is to say, feature creation, feature teams, they typically worry about profits and time to market. Component manager kind of organizations worry about quality, bugs, component performance. They typically have specialized knowledge as opposed to generalized knowledge, and they're really usually seen as a cost center. Let me talk about suites of products, because the differences that I've been talking about really show much more vividly when you have a suite of products. Think about the Microsoft Office suite, where you've got Word, Excel, PowerPoint, which is what I'm using right now, Outlook, and so on. The choice is between silos, that is to say, each application is independent of the others, developed independently, or shared components, which currently Microsoft Office doesn't have. If you have the silo approach, as you'll see, you have redundant code, and more code means more bugs, inconsistent user interfaces. If you've ever used the Microsoft Office suite, you know what I'm talking about. And cross-product incompatibilities, trying to move a graph, for instance, from Excel to PowerPoint, doesn't always work the way you expect. Anyway, so let's look at product silos. So here's three products that we'll assume for the moment that the GUI, the graphic user interface, is implemented 3 different times. The database, the internal data in the database is implemented 3 different times, and so forth, which means that if you want to move information between one of these products and one of the other, like the example I gave of taking a graph from Excel and moving it to Word, you need, sorry, hit the wrong button again. You need to write a program that moves from one format to the other, and then one that goes the other way, and then ones that go between the other two, and then ones that goes to be the third pair. So for 3 silos, you have 6 programs to convert data between the two. 6 programs you wouldn't have had to write if they were common, if it was common architecture, and 6 programs that have bugs, because every program has bugs. If you look at the common component case, the idea would be that GUI would be the same code in each of the three products. The database would be the same code. One product may have slightly more elaborate user interface, and so it has more of the common code, more code that could be used for other products, and so on. The idea here is that you're writing much less code and in a more general way, so that not only do you have less code to write, but the user interfaces, for instance, are more consistent, and the ability to transfer objects between one product and the other is trivial rather than requiring some kind of a conversion program. So again, just to summarize, component ownership, the people generally specialize in the technology of that component. Feature development people are generally generalists. They have to know the whole product. And everybody, and if you get two software engineers together to argue about how to do database or how to do a user interface, you'll generally have people with differing opinions. One of the things you might notice if you're an Apple user is that Steve Jobs did the tie breaking of user interface design at Apple, and he's no longer there. And the user interface is starting to get, as you'll see later, starting to get a little inconsistent. Priorities are different, as I said, and the support functions are different. So let's look at how do you optimize the build and test process as a different topic. The idea is to design the product that you're trying to put together so that you can manufacture it easily. That means so that you can build and test it in controlled stages. Having all the pieces come together all at once doesn't work. IBM tried that in the 60s and the 70s and built software that you couldn't even boot or initialize without having every piece working. And it just makes the testing time horrendous. The key to solving this problem is to manage the dependency patterns. And this is a simple way to look at it, but if you look at if you look at these diagrams, what I'm showing is 9 components, just as an example, and the arrows show which component uses which other component for functions. So the one on the left is an example of what a dependency pattern would look like that would require you to get everything working before anything works. The one on the right, of course, you could build in stages. You do component 1 and test it, make sure it works, and then you can do 2 and 3 using 1. And then you can do 4, 5, and 6 using 2, 3, and 1. Then you can do 7, 8, and 9, and so on. Much simpler, much more rigorous, and much more easy to predict and control how you build things. I could go on and on about all this, the build process. I just wanted to give you a taste in this presentation. Now let's talk about usability. In my opinion, it's the most neglected part of software development. Developers don't seem to know how to do usable software, and in many cases don't seem to care. And I'll give you examples of what I'm talking about. And users put up with an incredible amount of junk, to put it mildly. And software engineers, in my experience, do not think the way typical users think, and they don't know it. Or if they know it, they think users ought to think the way they do, as opposed to the way they already think. So there's this kind of tension there. Let me give you some examples. I was filling in a data entry page on the website of the local power company, and they needed my phone number and, among other things, and my account number. I put the phone number in with no spaces. I get a diagnostic error message saying they wanted it with dashes in it. And so I put it in with dashes. Then I was supposed to enter the account number. I entered it with dashes the way it was shown on the printed statement I had in my hand for my account with this company. And then I got a diagnostic saying the account number had to be entered with no spaces. And they cleared the whole form and I had to start all over. Somehow I was being punished for not reading the mind of the developer. This is probably the worst example I've come across, but it's an example of somebody that either didn't care or didn't bother to test with somebody trying to do something with that software. The postal zip code versus city and state thing is another example where you put the city state in and then the postal code, and if they don't match, you get a diagnostic. And finally, some of the applications I've seen now start using the postal code first and then fill in the system and, fill in the city and state. An iPhone asking for a number and then putting up an alphabetic keyboard. It's kind of a kick in the face. I I recently did an analysis of all the standard applications on the Apple, and the way the delete key is used is completely inconsistent across the Apple, the standard Apple applications on a Mac. Okay, so let's look at how do you manage usability? I mean, how do you get around all these problems? How do you find all these problems? And of course, you can't manage what you don't measure. And usability can be measured. Back in the 90s, IBM had a corporate usability group that reported to me, and I learned a lot from them. And what they did was looked at how to measure usability by measuring task time, task error rates, and learning time. If you look at the graph on the right, the task time obviously is the time it takes to do a certain predefined task. Error rates, or how many errors the user made, and learning time is the time it takes for the task time and error rates to settle down. And that is the only objective way, in my opinion, to look at usability. You can use a user lab, a usability lab, to look at predefined tasks, which is what IBM did back 30 years ago. Or you can measure actual usage by instrumenting the software, measure task time, error rates, on all the rest. And in effect, you get a flow that looks like this. The top of the diagram, the width of the diagram represents how many times the code was entered, and there are either errors made, which you can keep track of, or people quit in the middle, and then they go on to the next field and so on. This is what needs to be measured. And if you can make a change that is an improvement, then you'll see an improvement in these numbers. If you make a change you think will improve it and it doesn't, you'll see a change also in the wrong direction. So you don't have to guess anymore. So you can look at all these statistics to tell you how well you're doing. I'll give you a moment to read them. Other sources of usability feedback. I have managed groups where we had help centers where users would call in. And as a consultant, after I left EMC, I also looked at the feedback from the groups that took calls from users. Typically what happens is they fill out a form at the end of the call that says what the nature of the call was. And sometimes they'll say, well, the user found a bug we hadn't seen before, a new bug, or the user found a bug we already knew about. Or the ones that I don't like are the user didn't use the program properly. It was a user error. That's why they called. Or they called about something that they didn't know how to do, but if they had read the manual, RTM stands for read the manual. If they'd read the manual, they would have known how to do it. And the third so-called closing code is works as designed. User called up, didn't like the way it worked, but the product works the way we designed it to work, and the user didn't like it. In my experience doing consulting, a lot of this information is gathered, but it's never looked at. When I was at EMC, I edicted that every time a user calls with a problem, it needed to be considered as a usability bug and fixed if possible. And it made a real difference in the usability of the products. Some other principles: anything or everywhere the user clicks or enters should result in some action. For instance, if the user hits a delete key, you ought to figure they're trying to delete something. And in any event, if it's not part of what's been defined, at least it ought to be recorded that the user did that, and if possible, ask them what they were trying to do. So you can use that feedback to improve the product. And then another one of my favorites is, user interface is changing and the old way of doing things being eliminated. You really shouldn't do that unless you know the old way is not being used anymore. And the only way you'll know that is by measuring it. Back in the 1960s, when I was a young engineer, I worked with a couple of guys whose names are here on user interface design, and they talked about the principle of least astonishment, which means the result of any user input should be what the user most expects and is the least surprising. And that, in my opinion, should still hold. And it's violated left and right in many of the user interfaces that I've used. For my birthday the other day, my daughter, who is a software engineer, gave me a poster, and this is a reproduction of what it said. So a user interface is like a joke. If you have to explain it, it's not that good. And I agree with that. You shouldn't have to be a software engineer or a teenager to understand how to use an interface. And in my experience, I have trouble using a lot of these interfaces, and I am a software engineer. So this is the end of part one. This is the first part of an abridged version, as I said. These are the topics that we'll talk about on the next part. And if you want to look and see what the whole thing looks like, you can get onto our Facebook page as shown on the link here. So I'm going to stop talking at this point and stop sharing my screen.
Thank you very much. That was fascinating. We're both engineers and we both love processes. And
Yes.
it seems like we're beginning to demystify software development. And let's go on with the Q&A. And I'd like to start with something personal. Allan, what set you off in your love affair with computer science?
Oh, good question. So I went to MIT as an undergraduate, and when I got there, I was convinced that what I wanted to study was electrical engineering, but audio. I was really interested in recording, and stereo recording and high fidelity and all that was a phenomenon of my teenage years. And I wanted to do that. In fact, a friend of mine and I recorded in stereo the Duke Ellington Orchestra, the Baltimore Symphony Orchestra, and a number of other orchestras that we bootlegged our way into. I got to MIT the second semester of my freshman year. They offered a course in computer programming to the freshmen. And the computer, by the way, was vacuum tubes. It might have executed 40,000 instructions a second. It was an IBM 704. And I fell in love with computers. And the guys that were teaching it turned out to be giants in the computer field. I was more interested, by the way, in how the computers worked and designing the hardware than I was in software. So my career started as a logic designer, designing the adders and shift registers and the like, the guts, if you will, of the computers rather than doing software. I actually never really liked writing programs, but that's how I got started. So I went through the electrical engineering curriculum, learned pretty much everything there was to learn about switching circuits, as they're called, Boolean logic circuits. When I got to IBM, they wanted me to go to work in the software part of the company, and I said no, I want to stay in hardware. So I got to work on the architecture of the new System 360, which was the architecture being the hardware software interface. So if you will, I gradually started moving up the chain, logic, then architecture, and then finally got dragged kicking and screaming into software. And that's sort of how my career began.
And I love that story. You started with hardware, you went kicking, screaming into software. It's like a typical career path. You start your career with knowing the technical stuff. Then somewhere along the line, as you rose through the industry, you began to handle people. I was fascinated by the fact that you said that you handled 200 people for a project. 20 people, I think, is already a handful. So what were your, yeah?
The biggest project I ever managed was 2,000 people.
Wow, 2,000. All right. So let me change my question. Whether it's 200 or 2,000 people, what were your management practices, your best practices to have all those people work together, coordinate with each other, and achieve the common goal?
Well, what we did was we organized the way I was described in this presentation.
Yeah.
So, for instance, one group had the data management part of the system. Another group had the communications part of the system. Another group had the basic kernel of the system, and so on. And and the compilers for Fortran and Java or different languages were also separated. So each group had their own functional responsibilities. And what made it work was the group that I managed, which coordinated everything. And the thing that held it together, and I'll be talking more about this in the second half, is the fact that in those days, people gave their word to do things and you could count on them. And that's what made it work. I mean, when I was running probably the biggest project I ever ran, which was, we had 19 groups in 11 locations. And we needed to add some more programmers. We found the 20th group in the 12th location and didn't think anything of it. Didn't think it was going to be a problem, and it wasn't, because we had designed the interfaces, people, between the components, people adhered to those interfaces, and they kept their word about schedules and checkpoints. And as I'll tell later, that culture in IBM disappeared after a while. Which to give you a preview is why Intel and Microsoft exist.
And that's going to be a fascinating behind the scenes insider look at the industry. And something came up in my mind. You mentioned that you love Duke Ellington, you love orchestras, and I can imagine you like being the conductor and all these software people, the 200 to 2,000, they're the musicians or the instrument players. I feel like imagine that's how you see yourself. Is that true?
Yeah, that's a reasonable analogy. I want to just add something to what you said earlier, which is, even though I went into management, what I discovered was that the problems that came to me were very interesting, because typically the problems that get escalated up to the higher level managers are problems that nobody in the organization could solve. And so they're really juicy problems, if you will. And the interesting thing is, if you could solve them, then you're a hero. If you can't solve them, you're just like everybody else. So there's almost no downside. So what I liked about being, managing these huge projects was the issues that I got to deal with were really interesting and really, really complex. And so on. So it's really just a function of the degree of difficulty and the level of detail that you're dealing with. So instead of trying to figure out how to write 3 lines of code, you're looking at how do you fit 1 million lines of code over here with 2 million lines of code over there.
My gosh, I can only imagine.
And it's interesting, yes. What else?
All right. And speaking of codes, you said a while ago that an investment grade software does need to be replaced, but from time to time, we do see the need for upgrading it or updating it. How do you reconcile the two? It's not to be replaced, yet you have to improve it through upgrading or updating.
Well, I mean, the functionality evolves. And what happens is if you look at, pick one of the office products like Word. I mean, in the beginning, it had a limited set of functions, and then users say, well, why can't we do this? Or let's have that. And so the functionality gets extended. So the idea is, can you extend the function without throwing what you've already done away, without throwing away what you've already done? And that's really, to me, the difference between investment grade software and throwing it away and doing it over again, which happened, in my opinion, in my experience, happened a number of times in the development of, let's say, the
Now, speaking of that software, you mentioned a while ago, this is the interesting part as well. You mentioned that software developers, they don't have an idea how the customer would think or feel. They don't think like the end user. Why do you think that's the case?
Well, for two reasons. One is, as you know, engineers don't think the same way ordinary people think. I'm sorry, it's true. And the other thing is that typically engineers don't use what they're building. So for instance, if you're doing, let's keep using Word as an example, you're doing a word processor, engineers don't use word processors particularly. They might do it at a trivial level, but they're not generating books or advertisements or whatever. So they don't have the point of view of a user. They have the point of view of the person on the other side of the interface, and it's a mistake. It's a mistake in the sense that many of the engineers I've managed have enough of an ego to think they understand what users want. Okay, and now you're going to get me into another subject, which is one of my pet peeves, which is programmers like to program. And so what will happen is programmers will find a user and say, wouldn't you like this really snazzy thing to be added? And then they'll go add it. And the fact is nobody asked for it, nobody wanted it. And if you look at Word, there's 50 ways to do everything. There's the user interface is scattered all over the map. And, there are things in there that I've been the user of Word since it was first delivered 30 years ago or whatever. And there's still things in there I don't even know what they do and I don't use. And, it was just some engineer decided it would be cool to put this in. So it's called, in some places they call it function creep. You tell the engineer to do a simple thing. And they say, oh, wouldn't it be neat if we did this other thing too? And again, you add more code, you have more bugs. Sorry.
Yeah, they want to put in the bells and whistles. I learned a new term, function creep. And I think what happened is the more you put some bells and whistles, the more complex it becomes and the more problems it would generate.
That's exactly right. That's exactly right.
Okay.
And, as engineers, you and I think, have the concept of elegance. In other words, a solution to a problem is elegant if it's simple, economical, and it works, it solves the problem. But simple and economical as a goal is not too prevalent in the software industry.
Which leads me to my next question. If you were to train the next generation of software developers or engineers, how would you do it?
First of all, I make them take engineering courses. And you know, my daughter is a software engineer who was trained as an electrical engineer, so she understands this conversation we're having. You take somebody that learned how to code in high school and never got any more education, and you know, they're valuable, there's no question about it, but they lack the discipline of somebody that's been trained as an engineer. And in my opinion, what's missing from them is the discipline of looking at problems as an engineer would look at a problem, trying to find an elegant solution, trying to do the minimal thing. You know,
Yeah.
I mean, that's what at least the electrical engineering I studied was all about.
Yeah, that's also a great reminder for engineers like me. Less is more. The simpler, the
Yes.
more elegant. Yeah.
Yes, yes.
And now let me ask two questions, this time from a end user's point of view. I have my own horror stories where I had billing errors from my credit card or my telecom company. And I have the suspicion, maybe you have this insider look as well. I have the suspicion that inside those companies, the software developer guys have their own silos compared to people in, let's say, customer complaint centers. So if I call up my complaint to this contact agent, she would register the complaint, but doesn't tell it to the software developers. There's a usability bug there, fix it. I don't think that's happening.
No, you're absolutely right. I
Yeah.
mean, I vividly remember in about 10 or so years ago, I was in Ottawa at a major telecommunications company, and they were having customer satisfaction issues. And so I said to them, let me look at the reports from the customer calls, you know, the summary sheets that summarize what each call was about. So they gave me a stack of paper. It might have had 500 sheets in it. It's, you know, this is from the last, you know, 6 months or whatever it was. And I spent 4 or 5 hours that night going through and compiling statistics. And I came back and I presented the statistics about what users were calling about. The management of this company had no idea. You know, I knew more about what their customers were saying about their software than anybody in the company knew, because I had looked through those sheets that nobody else had bothered to compile. And that, you know, that's that's a problem. And in my opinion, that ultimately slows the, you know, if you have a company that uses software in your business, if you have user issues, ultimately it's going to affect your bottom line. And it was in the case of this telecommunications company, except they were looking in the wrong place. It's a little bit like, you know, trying to find your keys, but you only look where the light is.
Ah, yeah.
Yeah, you lost your keys in the street, but there's a street light, so you look under the street light. But where it's too dark over there, I'm not going to look. Anyway.
Yeah, that's crazy thinking. Which, now, here's my second question as a user. Knowing all those things we talk about, the next time I file a complaint, how will that knowledge about software development help me in my complaint?
Well, it's a good question. One of the problems is you're talking to the wrong person, typically. You know, the people that answer the phone are there to, I hate to say it this way, but they're there to get you off the phone. And you know, I'm not, and they are helpful. I mean, I use helplines all the time. You know, for instance, I'll give you 2 examples. One, I have friends that are my age. They're both retired. One was a partner in a major law firm. The other one was a professor, a full professor of in the business school. The wife, and she wanted to return a dress that she had bought on the internet, and she couldn't do it on her computer. for some reason, it kept locking up and so on. And so I tried to do it. I couldn't do it. So she writes a note to the help group. She gets back a reply that basically told her to do what she'd already been trying to do that didn't make any difference whatsoever. So she writes back, said, I already did all that. What should I do next? They sent her the same note again.
Oh.
So I wrote, and I said, let me write a note. So I wrote a note. I said, either you send us a return, postage sticker to put on the package to send back, or we'll dispute the charge with American Express.
Mm.
So now there's consequences, and I found that's a lot of leverage. And guess what? 5 minutes later, here comes the shipping label for the return. So, you've got to be more aggressive with these folks, in my experience. There was the other example, the other thing is when I was working and had, responsibility for different products, I would get phone calls from customers that were routed through the office of the chairman of the board. So for instance, if a major bank is one of the customers and they have a problem and it doesn't get resolved, typically what will happen is somebody will call the CEO of the company I work for, the IBM CEO or the EMC CEO or whatever. And then I get a phone call from the CEO's office and say, make this go away, And it usually happens on a Friday afternoon, by the way. So I do the same thing. And I recommend it to everybody. I had a problem with my internet support here. And I wrote an email to the chairman of the board of the parent company of the company that provides internet support in my town. I got 2 phone calls in 15 minutes and they fixed the problem. So, the point is you need to talk to the right person.
That's the key.
And oftentimes you're not going to know who the right person is. You shouldn't have to know who the right person is.
Yeah.
The right person is always the CEO. Let them figure out who the right person is.
Yeah, that's true.
So that's my advice for people that need help from the help group.
Yeah, that's valuable advice.
Yeah, if you don't get it, don't waste your time.
That's true. And usually the people you talk to, the help center people, they have their own metrics, the amount of time you spend on the phone, your closure rate, that's their KPI. And then the software people have their own KPI and they don't jive to each other. The marketing people have their own KPIs too. So
that's right.
Yeah, that's one thing. Yeah, that's true. Let me give you one last question.
Okay.
I love the principle of least astonishment. That's brilliant. Are there other principles we would like to have when it comes to, let's say, project development or project management?
I'll be talking about some of them during the full course, but the first principle, in my opinion, is to always have a plan. Eisenhower was the general that ran the Allied forces in Europe during World War II. And he was the one in charge of, among other things, the huge effort to land our troops in France in 1944.
D-Day, I think.
And so he said, so I have a quote of him in one of my presentations, and what he said was, the plan is nothing. Planning is everything. So the way I would say it in a different way is always have a plan, but be ready to change it. Be ready to improve it. Be ready to deal with things you didn't expect or things that you didn't know how to do when you made the plan, that you discovered that you didn't know how to do during the course of the plan or whatever. But the point is you always need to have a plan, because if you don't, you'll never see the problems until it's too late.
Yeah, and that is true when new problems arise when you engage the enemy. That's a great reminder to all of us, especially for us into operations or processes. So Alan, this has been a great conversation. How can people get in touch with you in case they need your services?
The Facebook account is
Yep.
ALS Consulting. ALS are my initials. So the chart I put up at the end. So it's just facebook.com/ALS Consulting, all one word. And then there's a homepage that shows about my company, and there's a link called services. If you click on that, you'll see what we're offering.
And that's going to be a great resource. Thank you very much for your time. We'll learn a lot, Alan.
You're welcome. It was a pleasure.
That was a great episode. It's like drawing back the curtains of what software developers do. I had my two takeaways. One, always have customer empathy whenever you're developing a product or a service. Two, plan, plan, plan. Look forward to the sequel when Dr. Allan Scherr will present part 2 of his deck. In the meantime, join us next week for a brand new season. Yes, Season 7, Episode 1, where we will have Dr. Renato Joseph, who will talk about the Omicron variant, the efficacy of vaccines, when to get safely boosted, and when it is time to jab our children. Jab with the vaccine, of course. He will be interviewed by no less than the ever-dynamic Dina Loomis. Don't miss it. And remember, learning is a lifelong journey with limitless vistas. Good day. Stay safe, everyone.